episode of From the Outside Looking In, where we'll be discussing exactly what is happening in the body. Today's segment will include vitronectin and its role in the body, the long-term effects of unhealthy eating, and also signs and symptoms that diabetes may be occurring. First on our show, we've asked Dr. Vance, a hematologist from Ohio, to come and discuss vitronectin's role in the body and what exactly it does. Please join me in welcoming Dr. Vance. Good, how are you?
Good.
Thank you so much for coming and joining us today.
Thank you so much for having me. I love educating people when I get the chance.
So let's talk more about vitronectin. I know I've never done a segment on it. I really don't know much about it.
I'll try my best to explain the role vitronectin has in your body. In order to do so, I might use some pictures and visual aids.
Vitronectin is a relatively small extracellular matrix glycoprotein that has many functions. It is found in the plasma of blood, wounds, and other areas undergoing tissue remodeling. It is synthesized by the liver, which is different from all other extracellular matrix proteins. The liver then secretes it directly into the bloodstream. Vitronectin has two different structures that can be found in the body. There is the zipped or folded form or the unzipped form. When it is in the zipped form, it is inactive, whereas in the unzipped form, it is active. Vitronectin's structure has a significant property due to the ability to bind certain proteins to its specific domains. These type of proteins include collagens, integrin receptors, cell lysis factors of the immune system, proteases involved in degradation of extracellular matrix, and most notably clotting factors. It is vital these clotting factors bind to the correct domains with the proper site of the body through regulation, or else significant health problems can be experienced. This regulation is vitronectin's role in blood clotting.
After a short break, Dr. Vance will be back to further explain vitronectin's role in the body.
It's gonna be hot today. Open up an ice cold sun drop and show how you drop it. The pimp's in the crib, ma. Drop it like it's hot. Drop it like it's hot. Drop it like it's hot. When the pigs try to get at you, park it like it's hot. The thirst quenching citrus drop. Just drop coast to coast. Sun drop.
Welcome back to From the Outside Looking In. Dr. Vance, please continue.
Vitronectin circulates in the bloodstream at high concentrations of about 0.2 milligrams per milliliter in humans and must be unzipped to show all of its binding sites, thus promoting protein binding. How vitronectin unfolds is unknown, but it may be the changes in pH and concentration in plasma levels. In blood clot formation, vitronectin serves as a scaffold to ensure the proper placement of clots, which is very important due to the harmful effects that can be experienced if a blood clot is formed in the wrong part of the body. One of the most important domains within vitronectin is its heparin binding domain. Heparin is an anticoagulant and thus decreases blood clotting activity. Vitronectin's ability to bind heparin promotes clot formation by inactivating heparin. Within the vitronectin structure is also a plasminogen activator binding domain. This domain allows plasminogen to bind, which is the precursor of the primary fibrinolytic protease. Located within close proximity is the plasminogen activator inhibitor domain. This domain allows the plasminogen activator inhibitor to bind to vitronectin and cause stabilization. Due to the close proximity of one another on the vitronectin binding domains, the stabilized plasminogen activator inhibitor can then inhibit the plasminogen activator and halt fibrinolysis, thus promoting a clot formation.
Thank you so much for joining us today, Dr. Vance. You did a great job explaining vitronectin.
It was my pleasure.